Okay. So first we'll do here electric dipole. Then we'll do question for that. Okay, let me disable this. Yeah, 18 ohm disable. Okay, dipole, from the name itself we can understand it has dipole, 2 poles. So electric dipole means dipole which is electrically charged. So they are equal and opposite. 2 equal and opposite. So they are electrical dipole or electric dipole. Minus Q plus Q, which is separated by distance from the center, total to L. So from the center, we can say here, not from center, but distance between them is 2L. Some finite. Actually, this 2L will be very, very small, very, very small. So there will be a movement of dipole. So we will say dipole movement P, which is equals to Q into 2L. Now, if you remember moment in your 11th standard, it was force into perpendicular distance. That was torque, right? Force into perpendicular distance, it was torque. You apply force, it got rotation, that is torque. So here dipole movement of electric, that is charge into distance. SI unit will be, what will be SI unit? Can someone tell me?
Coulomb meter.
Coulomb meter. Okay. Now this is a vector quantity. This is a vector quantity. SI units we wrote, formula we wrote. What else we need here? Okay, let's write about torque then. Torque on dipole will be equals to tau equals to force, QE, force into distance into sin theta. This is the distance, this is the force. Force into distance. We are taking perpendicular. So if it is this one, so this will be a sine component from your opposite to this one. So this is this direction. So opposite to this one, we will take a sine component. So this is a distance. 2L is a distance. So now this is force. Force, if you remember, equals to QE. So torque equals to QE 2L sine theta. So that we can change it to PE sine theta. Q2L is P. Just now we wrote. So P equals to PE sine theta. Sorry, tau equals to PE sine theta. Or we can say tau equals to P cross E. Excuse me. Make a note of it. Done?
Yes.
Everyone? You able to understand? Samita, Rituraj, Lingraj, Laukya, Rishi, Bhanuti.
Yes, sir.
Yes, sir.
Okay. Others? Easy, right? Okay. They're writing in chat box. Okay. Super. Chalo. Next. So if I want torque to be maximum, torque means rotation. Rotation, I want maximum here. So what shall I do? What shall I do if I want maximum torque?
Sine 90 degrees.
Means I should keep P and E perpendicular. And if I want minimum?
And should be parallel.
Parallel or anti-parallel.
Anti-parallel.
Right. Yeah. So tau should be maximum when P perpendicular to E. Or we can say dipole is perpendicular to electric field. Perpendicular electric field. That means 90 degree. And minimum when they are parallel or this is 90 degree, this is 0 degree. Guys, I think you have studied in mathematics, right? Little bit mathematics in your 11th standard. Any of a non-math student?
Sir?
Is anyone a non-math student? Yeah, pure science, I mean. There's like few things.
Yes. Yes, sir.
Sure.
Oh, okay. I'll try to make it easier. But guys, you know vector multiplication, right? In first you're studying in like straight line, mostly in straight line,
Yeah.
then it will be okay. Okay, then let's P equals to P of xi plus py j pz k. And E equals to EXI plus EY J plus EZ K. Then tau equals to PE. So I component, J component, K component, I can write here P of X, P of Y, P of Z, P of X, P of Y, P of Z. You can find determinant with this. No need to solve, let it be. Okay. I'll write some formulas related to this one, similar way I wrote for before. First one. Along axial line. Axial line means along the axis. Or we can say, or any end position, end on position. So this is the distance apart, we can say to L, and we are taking a point somewhere along the axis, that is P, electric field here. So from center, the distance is X for P, position P, towards P. So first understand the distance, okay? This is total distance between Q and Q, plus Q and minus Q, is 2L. But distance from center of a dipole to the point anywhere on the axis is X. And one more thing you have to keep in mind, that 2L is very, very small than X. Okay, it's not big. Here we are drawing so big, but it's not so big. It's dipole moment, like it will be so small. Charge will be kept very, very near. Then only it will have attraction force. Okay. So let's write a formula for P E parallel. So E for axial point 1 by 4 pi epsilon naught 2px by x square minus L square the whole square. X is very, very bigger than L. This is the formula. In some book, it will be like they're taking A here. Some book, whatever variable they're using, it doesn't matter. Next, along equatorial point means any like some point aside of we can say axis. And the side. So this one we can name it as some far side or a broad side, we can say, or broad side position. So let's draw it here. Point Q plus Q at some point P at a x distance. So we are not deriving here again, like all this triangle laws and all that we have to do. No need to do that. That you will learn in your school itself. Here we'll solve some JEE questions after this. Okay, so equatorial point. Same formula for pi epsilon naught here, P by x square plus L square 3 by 2. Again, x is very, very greater than bigger than L. E x is equals to 2 times of E EQ when PL ER parallel. Third one, last one.
Could you scroll up?
Yeah, sure. The first one or second one?
Second one.
ठीक है.
Yes, sir.
Okay. Third one, at any point. So dipole, you can say 1 by 4 pi epsilon naught p by x cube. P cos square theta plus 1. So let me draw here. Any point P, making angle theta along x-axis here, resultant E, and this will be your EY. Again, this distance x only. So this angle, resultant angle is at beta. So tan beta equals to 1 by 2 and theta. At any point, we can say it is inversely cube root. Sorry, cube. It varies inversely as a cube of the distance, you can say. Here also cube. And in this one also cube. So in short, we are saying what? Electric field at any point or electric field intensity due to like all these three equations we saw, or it varies inversely as the cube of this x is the distance. Okay, some formulas which will be required, we'll write that. Electric, I forgot C here. Electric force I've done writing this one. बच्चे लोग are listening?
Yes, sir.
Yes, sir.
ठीक है. Ajay is absent. Okay, so for first one, force equals to 1 by 4 pi epsilon naught 6 p1 p2 by r to the power 4. See, p1 and p2 are dipole moment. And this formula is for when dipole are placed coaxially. Next, 1 by 4 pi epsilon naught 3 p1 p2 by r to the power 4 when dipole are placed perpendicular to each other. Now, can someone tell me what do you mean by coaxially?
On the same axis, I guess.
Yes. They share common axis. Yes, you're trying to say something? Okay, then let's do numerical. Numerical. Free. Oh, fine. Okay, this question requires time period also. So let's see how much you remember, or else I'll give you formula. Don't worry. Not time period, simple harmonic motions. No, this is a mixed question. Okay, let's see. This was asked in some 2000 question. Consider object mass m and 3m separated by a distance L. Charge Q and minus Q. Are placed on them respectively. And they are lying in an electric field E. Frequency oscillation SHM. Okay. Consider it is SHM. some center of mass and such conditions we need to consider here and do it. Come on, try it first. Sorry, try it first. I'll solve it. Don't worry. You try. If you can't, I'll solve it. Anyhow, I have to solve it here because it's recorded. If any other students see, they need to answer. Excuse me. Come on, guys. I'll try it. Okay, turn on your camera. Let me see how many of you are trying. Everyone, turn on your camera. Samita, Rituraj, Nimraj, Laukya, Drishi, Bhanuri. Quick.
Sir, I cannot. There's some issue here.
Okay. Others, quick. Turn on your camera. Rituraj, Nimraj, Laukya, Rishi. Okay. Yes, guys. Anything you're getting? Any idea? Something? Shall I solve? Yes or no? Or you want me to wait for a few minutes? Tell me quickly. Okay, then I'll solve. Okay, 1 minute. Fine. Come on, give it a try. Let it be right or wrong, doesn't matter. Who cares? After this, I'll give you some exercise to solve. 15 question for practice today. So by next time when we meet, you should be able to solve those questions. Okay then. Let me solve this question. Now what it says, consider two objects. Okay, let's consider of mass m here. Point here, m. Separated by distance, it is 3m. Okay. L. This is some CET question, any set CET question, some state. One is Q, so force will be QE. Force will be QE. Placed on them respectively, they are lying an electric field at angular frequency. Okay. Now for finding, we need to find center of mass first. X cm 3 m L plus 0. If we take some center O, let's take some O from here. And 3 plus 4, 4m. Center of 3L by 4. So this is your 3L by 4, and this is how much? L by 4. L by 4. This is 3L by 4. So even this is obvious. If you don't calculate also, it is obvious because this mass is more here. So we need to hold our object near to the greater mass, so that then only it will be in equilibrium state. Then only it will be like holding that. So even like a center of mass will take it as positive only. In this case, it will not move if we keep on this place, like holding at the near to the center greater mass. It will not rotate, it will not move. So no torque here. So we can say tau equals to QE A sine theta. And tau also we know in system particle we saw that is I center of mass into alpha. And alpha equals to d square theta by d t square, because we want your angular frequency. So I'm bringing it this thing here. Okay, what else we can make it change? We'll take this one is equals to theta only. It's very small. Small oscillation, we can take it here. Fine, let it be. What else we can change here? I alpha, we got it here. D theta here. Okay, we want theta only. So I can say here ICM equals, no, not ICM, sorry. D square theta by dt square equals to Q E L theta. Did I miss anything? Okay, that's it. So d square theta by dt square, which is equals to omega square, which is equals to Q E L. If we differentiate this one, it will be 1. Theta will be 1. So I center of mass. Now we need to find I here. If we find I center of mass for this one, this is what? To object of mass up to the distance here. So 3m is okay. Next is L by 4 square. Mass into L square. 3m L by 4 whole square. Plus that is m. It was 3 L by 4. The whole square. Which will give you 3, 4, 4, 16, 16. Nine plus 3, 12 by 16. Again, 3 by 4 ml square. Okay, then let's substitute this one here. So finally, omega square equals to Q E L by 3 by 4 ml square 4 by 3 QE by ml, or under root. Let's see. Did we miss anything? Okay. So what I did here, first of all, I found your center of mass. No need to do that also. It's just common thing. It's more mass means it will be 3/4 of it. and it will be 1/4. Then tau equals to force into distance. So force here it is QE. Distance is here L because it's separated by distance L. L sin theta. Theta equals to I alpha. I is moment of inertia. Then alpha equals to d square theta by dt square. So d square theta omega square. That is Q E L by ICM. So we need to find ICM, center of mass. So mass into length square. So here length is here L by 4 and here 3L by 4 and square it over. Are you guys understanding what I'm doing here?
Yes, sir.
Is it confusing? Are you feeling confused or is it okay? Everyone?
Understood, sir.
Others? I got it 2 only. What are others? Okay. I'll post this question here in your group. 15 questions are there. Okay, try to solve it yourself. Don't need to ask a Sundar Pichai or Safari, whoever it is. Okay, try yourself. If you can't get, we can solve it here. But I guess you will be able to solve. It's not that tough. Some basic questions. Okay, guys, then see you in next class. Do you have any doubt in today's class? Anything?
No, sir, no doubts.
No, sir.
Okay. So next class we will do here like flux and Gauss law, all this. That means with that our chapter will be over so that we can solve all this PMT question combinedly. PMT, IIEEE, means and all that. Okay. Okay, guys. Bye bye, everyone. Keep practicing whatever question you have.